Unit conversions, changing a unit from one kind of unit to another. So, for instance, you have a certain number of inches, you want to know how many feet it is. You have a certain number of centimeters, you want to know how many miles it is. Or you have a density in kilograms per cubic meter, and you want to know what that would be in grams per milliliter. The first thing we should probably point out is that if you want to convert between two units, they have to measure the same thing. You can't convert, for example, from centimeters into days. They just, they don't measure the same thing. This measures length, and this measures time. And so you just can't convert two things unless they measure the same thing to begin with. First thing to realize is that you must have a conversion factor. You cannot do anything without a conversion factor. A conversion factor is something that states what amount of two different things are equal. Examples. 1 gallon is the same thing as 8 pints. 1 mile is the same thing as 5,280 feet. 1 kilometer is the same thing as 1,000, or 10 to the third, same thing, meters. So those are some examples. A conversion factor is just a statement of two things, two equal quantities in different units. So, how do you use these to do a unit conversion? Well, let's do a quick example. How many inches are in 78.4 feet? So, the way that I'm going to do this, I'm going to ask that you do it the same way that I do it. You might say that this is silly because you know how to do this without doing it my stupid way, but I assure you that I will give you some other problems later that you probably will not find easy, and you'll like to have an algorithm. An algorithm is a set of instructions, a set of steps that will always help you to get the right answer. So here's what we're going to do. How many inches are in 78.4 feet? The way that we approach a problem like this is we begin by starting out by writing out the thing we know and its unit. We start out that way. And then we're always going to put that thing onto a chart. This is called a dimensional analysis chart. What we're going to do here is this kind of chart. It's a mathematical tool that will help us to keep track of our numbers and to keep track of our units. So the way that it's going to work is any number or unit that we write on the top will be multiplied. Any number or unit that we write on the bottom will be divided. And the third thing to remember is that whenever when you put in a conversion factor, remember the two things that are equal, you're going to put one of those things on the top of the chart and the other on the bottom, the two different things that are equal, because then you have multiplied and divided by essentially the same quantity and therefore not changed the overall value. So let me show you what I mean. Our conversion factor here, we need a conversion factor that goes between feet and inches, and most of us know that. Most of us know that 12 feet is equal to, whoa, I just did that wrong. Excuse me. 1 foot is equal to 12 inches. So I need to put one of those things on the top and one of them on the bottom, and I'll show you why I'm putting 12 inches on the top and 1 foot on the bottom. Because now I have let's look and see what we're going to do here now. Now remember I said that things along the top get multiplied, things on the bottom get divided. And so that accounts not only for numbers but also for units. Now a little bit of review from algebra. If I have something like x and then I divide it by x, you may recall that those cancel each other out and they just turn into 1. And so here I have the unit foot on the top, feet, foot, plural, doesn't matter, and we have foot on the bottom, and we're going to divide that. So we're going to divide foot by foot just like we would divide x by x, and those are going to cancel each other out. And so now, unit-wise, we no longer have the unit foot. We have canceled it out, and the only unit that we have left is inches, and that's what we wanted. We want, when we're done, to have the answer in inches. So we know the units work now, and so all we've got to do now is find the number. How many inches. And so we look at the numbers that are remaining. The numbers are 78.4, 12, and 1. And what are we going to do? We're going to take 78.4 times 12, and that's 940.8. And then we're going to divide it by 1, which still is 940.8. So we have an answer of 940.8 inches. So that is how many inches you would have, but we should probably ask ourselves the question. We just got done talking about significant digits. Now remember that according to the old rules, the rules of significant digits, we now need to look through the problem and see which of these numbers has the smallest number of significant digits. But before we do, let's look at this. One thing that we're going to assume is that all conversion factors that we use are exact. In other words, they're infinitely precise. That there is exactly 1 foot in exactly 12 inches. So we could just as easily have written 1.00000 with an infinite number of zeros after it equals 12.0000000 with an infinite number of zeros after it inches. And so that is actually true. That is an exact measurement. And so really our number of significant digits are not limited by the conversion factor inches to foot. So we really should not look at those numbers. If we're going through here and counting sig figs, we shouldn't look at these. We should think of this as 12.000, 1.000, and that's not going to change our number of sig figs. It's really just this that we're going to look at. And so that's true in a lot of our conversions, but not all. And rather than needlessly complicating things by trying to remember which ones are infinitely precise and which ones are not, we are always going to assume that all conversion factors that we use are exact. And it's sometimes usually true, but not always. So what does that mean? What it means is that the answer in a conversion factor problem will not have its significant digits limited by the conversion factors. And so what does that mean? Well, it means the answers will have the same number of significant digits as the starting number. Always. For a conversion factor. So when we do a unit conversion, the number of significant digits that we end with should equal that which we started with. So if we go back here to our example, we have 78.4. That has 3 significant digits. So our answer should have 3 significant digits. It doesn't right now, so let's round it to 3 significant digits. Oops, m's. What's an m? 941 inches is the answer there. And so that's how we would do that one. And that's actually what we call a single step conversion. We did that all in one step. Now let's talk about a multi-step conversion. How many seconds are in 1 decade? Well, we do not have a conversion factor between seconds and decades, so we cannot do that in a single step. So what we're going to have to do is do a series of conversions, and we can do those all in the one-dimensional analysis chart. We don't have to make several charts. We can just make one and just make it stretch it out left and right. So what do I mean by that? Well, let's start with what the thing we know. We know we start with 1 decade. So I'm going to write 1 decade. And by the way here, I'm going to think of a decade as an exact period of time, not a measured period of time. So we can think of this as having 1.0000. We can have as many zeros after it as we care to write. 1 decade for significant digit purposes. And so then we have to put a conversion factor in here. And the conversion factor is going to have to relate decades to seconds, but we don't know that. What we do know is how many years are in a decade. And there are 10 years in 1 decade. So I need to put 10 years on top or bottom and 1 decade on the other place. And as we remember from before, the thing we want to get rid of, decade, is on top. So whenever we write the word decade again, we want it to be in a place that it will cancel out that decade. So we're going to write it on the bottom. So we have 1 decade. Now those will cancel, top and bottom, is equal to 10 years. Okay? Now, next we want to figure out, well, how do we get from years to seconds? Well, we probably don't know that one either, but we do know years to days. So again, I want to get rid of years and make it into days, which means that year needs to go on the bottom so that I can cancel them out. So 1 year is equal to 365 days. Now it's really more like 365.25 or 249, but we won't deal with fractions of that right now. We'll just pretend that's exact. Then let's get from days into seconds. I don't know that one either, so I'm going to go get rid of days. What do I know about days? Well, I know there's 24 hours. 24 hours. So there's one day and 24 hours. 1 hour is, I still don't, well, I actually do know that. You probably don't have that memorized. So what would you do? Hours to minutes. You know that 1 hour, get rid of hour, is 60 minutes. And that 1 minute is 60 seconds. And so if we look through here, we can see that things on top and bottom cancel. They go away. They pa-choo, 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 day, day, pa-choo, pa-choo, hour, hour, pa-choo, pa-choo, minute, minute, pa-choo, pa-choo, and we're left with seconds is the only thing that doesn't get blown up. And when we go through here, we'll see that this actually becomes kind of easy to calculate because there are no numbers on the bottom other than 1. So we're going to take 1 decade times 10 years times 365 days times 24 hours times 60 minutes times 60 seconds, and I get a rather large number, as you would expect, 315360000, and that would be 315,360,000 seconds in a decade. And I can keep, basically, if I like, I can underline that 0 to show that they're all significant digits because I have infinite precision, because this is a definition sort of thing, which isn't exactly true because the 365 days in a year isn't exactly true, but we'll let that pass for now. So those are the basics of how to do a either single step or multi-step conversion using a dimensional analysis chart. You find your conversion factor, you write out your numbers and your units, and then in your conversion factors you write the thing you want to cancel out across from the thing that it's canceling, top to bottom, and then you put the thing that thing is equal to on the top. So we have 1 decade, then you put decades per the thing you know on top. These two things are always equal. 365 days is a year, 10 years is a decade, 24 hours is a day, 60 minutes is an hour, and 60 seconds is a minute. And that's how you do a simple unit conversion.